Okay, it's working fine now. Okay, so today we'll be discussing these following topics: Python operators, conditionals, loops, nested loops, comprehensions. So if you notice, for this month agenda, we had so many topics. Whatever possible, we will try to complete. So we are here: Python operators, conditionals, loop, nested loops, and comprehensions is what we will cover in 2 days. And then after that, I want to talk about collections module, very important. And then functions and variables, recursion, decorators, generators. So I will add few more topics here. So we will discuss those. Okay. Um, let's get started with operators. Okay. Now Python operators, as you can see. Okay, Python operators, as you can see, so there are of several kinds. Here, as you can see, 6 to 7 types are available. Mainly arithmetic operators, comparison, logical, bitwise, assignment, and identity operators. So we'll look at arithmetic operators first. So if you notice, I will add all this information here on your sheet. So arithmetic operators. Um, mainly are you addition, subtraction, multiplication, division, and then calculating the quotient, which is your calculating the quotient, calculating the remainder. Remainder means modulus operator. Quotient means your normal division. Normal division gives you quotient. Modulus that you see here will give you the remainder, and then you also have power calculation. Okay, very simple. You can start typing alongside with me. So arithmetic operators are just addition. So you can directly type, try to calculate numbers, and you can also calculate the numbers inside a print statement, whatever it is, whatever you want to add basically. If I add e, okay, e is not defined, but if I add let's just say for now I will add 2.7. Okay, 2.81. So you can do this, or you can also have something called uh, I will do this eval. Okay, while accepting the input you can calculate. So 2 plus 3, if I say, and then I calculate var. Okay, fine. So this has to be string, sorry. So this has to be string, but when you pass some mathematical statement, it will still calculate. So if you notice, it has calculated 2 plus 3 is 5. So this is same as accepting the input that we saw in one of our previous classes. But it's just that the difference between input and eval is, input will only accept input, and eval will also accept input, but it will do the calculation. Input won't do the calculation, but eval will do the calculation. Okay, so this is simple arithmetic operator. And let's just say, same thing applies to your subtraction as well, right? So you can accept some number as 56. Okay, b is equal to 34, and then you can do my a minus b. Okay, this is your arithmetic operator. You can do a into b also. Okay, I'll type here. You can do a into b also. Okay, you'll get 1904. You can do a divided by b also. So that is your division, and then you also have power. If I type 2 to the power of 5, so it has to be 32. And then you also have calculations, right? So division you anyway have. Notice this division and this division. See, this is called as, okay, let me write it here, so that would be better. This is the normal division, which means you will get all the values, okay, after a point. But this is called as floor division. Okay, floor division means it will only return the values before this point, decimal point. Okay, no decimal points will be returned, only the actual number, how many times it is able to divide, that it will give you. So basically, in other words, it will give you quotient. That's what it means. So, and if you do A mod B, A percentage B is mod, and here what is the value of A? A was 56, B was 34. Let me take simple example to explain. 2 mod 3, okay, 7 mod 3, okay. So 2 is not divisible by 3. The way how it works is, so basically you have, sorry, so basically you have 3 here trying to divide 2, 0 times it gets divided, you get 0, remaining is 2, 2, okay. So this is your mod, and this is your quotient, this is your floor division, okay. um, so if you try to divide, do a floor division as well, if you do a 2 floor division by 3, you get 0, okay. How did you get that 0? This is how. So this floor division is nothing but your actual quotient, remainder 2 is your mod value. So that's what is being calculated here. Mod, floor division, power, division, multiplication, subtraction, and addition. These are all the arithmetic operators. Very straightforward. There is nothing new to it. Okay, very simple. Is this understood? Before we move on to next set of operators.
Yes, Sadik.
Okay.
Yes, sir.
All,
Yes. Yes.
okay. Okay. All right. So comparison operators.
Hello, Sadik. That eval 2
Mm-hmm.
plus 3.
Mm-hmm.
Okay, that is only one operator we have to calculate with the string, or we have any other methods?
Other methods, as of now, I am aware of only one. If I find, I will
Oh,
let you know. But while accepting input, okay, that is where we usually use eval. Okay, but if you
okay.
wanna convert this
Sorry.
to integer, okay, let me try that. So if you wanna directly convert, we call it casting. Okay, so it doesn't work. Okay, but if you had only one number, then it will be converted to integer, okay. But the actual calculation from string, so we don't, I don't know of, I'm not aware of any other thing, any other method that does this, but if I find out, I will let you know.
Fine, sir.
Yeah. Okay, so next is comparison operators. These are very basic ones, what we have already studied in um, schools, right? Okay, so 1 second, there is something I need to show here. Okay, all right. So, so if you want to compare two operators, right? So let's just say, um, A. I will define A is equal to 2. I will also define, yeah, A is equal to 2, B is equal to 2. I think we already talked about this, but still, if I want to know the address of both of these, okay, you notice something, they are exactly the same. Okay, this we already talked about in the past. So the value assignment, the way it happens is, if the value is same, both the variables are assigned to the same value. Okay, if I do here something like um, they are on the same address, by the way. So if I do A plus 2, okay, um, and then I want to print B. So here what happened was, initially they were at same level, okay, same values, because values were same, the pointer was pointing at the same values. But now we, because we added 2, the pointer for A incremented to next two spaces. Now if you check id of A comma id of B, you will notice that, okay, A plus 2, oh, I didn't assign, I'm sorry, A is equal to A plus 2, I will say. Okay, A is equal to a plus 2. Okay, 1. I think it didn't modify the value 4. Okay, a become 4, and now if you notice, the address changed. Okay, from 688 it went to 752 with different address. Again, don't worry about these addresses, how they are getting assigned, because depends on the what is the memory available and at what place the memory is empty. So all those things are taken into account. So just don't worry about these randomized numbers, but just notice that only after value assignment it increased. Now if I say I will roll it back. Yeah, I'll do a is equal to a minus 2. Okay, now I will check id of a, comma, id of b. Now see what happened. Because the actual end result was the same, they are equal, they are pointing to the same address again. Okay, if I want to compare is a equal to b, it will return me true only because, only and only because, not because these values are same, but because their addresses are same. This you must notice. Okay, uh, because they are pointing to the same value, and they will point to same value only when the, obviously, when their values are same. Okay, but this operator is designed in such a way, or if okay, let me type one more, maybe you'll get better idea. You see, in this case both are same. Okay, is a I'm checking logically whether a is b. Okay, here I'm checking a equals to b, so both are returning me true because one is comparing the address, one is comparing the value. Okay, is this clear? For equal to, um, if you didn't follow, it's okay. You just remember that in order to compare the values, we use this double assignment operator. Okay.
Sadiq, for every number,
Mm-hmm.
so there is ID assigned, right? For
Correct.
every number.
Correct.
Okay, so that is what like the ID what is showing A and B
Mm-hmm.
is assigned with the numbers, right? So
Mm-hmm.
if we use this boolean to check whether it's true or false,
Mm-hmm.
okay, so with the help of numbers, we'll identify whether it's a true or false, right?
With the help of IDs, it will check and confirm.
Yeah, ID numbers, right?
Yeah.
So
Yeah.
background, that is what they are playing, right?
Yeah. Yeah. So,
Oh,
but
oh.
these addresses, they are not necessarily for numbers. If you notice,
Mhm.
this is completely like list, right? The list of numbers. It could be a list of strings also. It is not
Mhm.
exactly dependent on this value, but how do I put it? It's not exactly dependent on the numbers, but the entire value. Okay, entire thing, whatever it is.
Okay.
Okay, so if you had here
So,
something like good morning, okay, then also this ID would get assigned, um, but it is not assigning for either G or O or D, but instead everything is taken as one single thing and assigned. Is
so
this
it will
clear?
work for set. Yeah, it will work for list, set, and tuples also, right? Dictionary.
It will work for basically anything. So
Okay.
if you have here, so it will work basically. ID is just used to see where the address number where it is allocated in the memory. Okay. All right. So a equals to b. This is very clear, and now pretty much straightforward is a greater than b. Okay. Sorry, b, I changed the value, right? Let's just say a equals to um, 3 comma 4 comma 5, and b equals to 7 comma 4 comma 6 comma something. Okay, I will add equal number of values. Now a, we are checking is a greater than b. False. A is less than b because one number is higher, and you can compare B is B greater than A, which is true, which we can see here in the values as well. One number is high. You can basically compare same type of values. Either if you have number here, you can compare with it number. If you have, let's try with strings. I have never tried with strings though. Let's just say good morning. Is good morning greater than good evening? Something like that. Good evening. Okay, that is also true. Why? Maybe because it's trying to compare the letters. Okay, and you remember the ASCII encoding, right? So for first 5 letters it would be the same, and for the sixth letter, if you notice, this has higher value as compared to E. E comes first, M comes later, so this is being taken as greater value. That's why it is returning true. So basically, if the values are same, for example, if you have number here, number, tuples, dictionary, that way if you have, so you will be able to use these comparative operators. Okay, next let's try 3.45 less than or equal to 3.44444, sorry, 499999999. So you can still see it has, it is able to compare just fine, and you can check the other operators. What is the other operator? Not equal to. When you want to check if something is not equal to another thing, you can use not equal to. For example, if you want to compare um, string, is it not equal to another string, string, but this time I will add a dot. Okay, so it is true because they are not same. One dot is extra, right? So that's why. And then you again have, what are the other operators you have? Greater than or equal to, less than or equal to. Okay, so you can write your own set of code if you want to check. Let's just say uh, if condition, I have not talked about it, let me skip it for now. So if you want to check is 130 less than or equal to 131, something like that, it will be true. Likewise, greater than or equal to will also work. Okay, so pretty much that's it about comparison operators. They are very straightforward, just like arithmetic operators. So there is nothing strange about them, no need to break your head. So it's pretty much same, very straightforward. Okay, logical and, these are interesting. Okay, logical and logical not gates. So these I need to talk about. We need to talk about a little bit here. Okay, all right. So logical and, I think you already have, either if you have studied engineering or if you have studied even in your mathematics in college days, we had something called truth tables, right? So for and it was something like this. So if you had true, it used to be true, true, false, false. Okay, false, true, false, and then you had false, false, false. So here true means 1, okay, false means 0, that much you remember. And then for OR table also you had true, true, true. This is true, false, true, and then this is false, true, true, and then this was false, false, false. So again the same thing, and then for not, it was something like if you had true it would negate it, and if you had false it would negate it back to true. Okay, so this is the same concept that we have here in Python. There is nothing difference. If you wanna but the catch is here. Okay, and there are certain things that are taken as what is true and what is false. This is extremely important. So anything that is zero, anything that is zero means only zero, right? Zero is false. Any other value, any other value is taken as true. Okay. So that this you have to remember. Any other value is taken as true, only 0 is taken as false. Along with this 0, interestingly, in last class we found out any empty list, empty tuple, empty set, basically empty string, these are all taken as false values. Okay, anything empty is also taken as false. So this we will see now. Okay. Okay, so let's just say you want to calculate 15 and 78. Okay, so it's returning 78. Again, one more thing I wanted to tell here. So this will anyway and will return sometimes. Okay, this returns and gate returns, okay, bigger value. Or will return smaller value. Okay, this is another point you have to remember. So between 15 and 78, because it is any other number other than 0, it is taken as true. This is also any other number other than 0, hence true. So true and true is again true, but it will return the maximum value. So that is how AND is designed. Okay, AND returns bigger value. Okay, and 0 is considered as, okay, this I will write separately. Okay, so here it will return bigger value. You can test with other values as well. 15 and 78. Let me import infinity. This we activity is quite interesting. Math dot infinity. Let me check. Yeah, infinity you have. So I'm going to compare infinity with -1. What do you think should be the answer? Can anybody tell me? Don't execute at your end and check and tell me. Just top of your
-1
head.
it should be.
Okay, -1. Why is -1?
Uh, false, true. No, true, false, false. That's it.
No. Even -1. Okay, let me show you. -1 and -2 is -2.
Right.
So what is happening here is um, even infinity is taken as true only. True, this is taken as true, and this is also taken as true. Hence you get some value. Otherwise you would get false, or you will get 0. Okay, that let me show you that example also. -2, you see, you got 0, right? Because it failed, this condition got failed. So 0 means false. Or if you want to print, okay, so print also will give you the same thing. Anyway, so what is happening here is when both the values are taken as true, you will get the largest value here. Because you don't know math dot infinity, uh, here it is considering math dot negative infinity, which is much smaller than -2. Hence you are getting -1. Now here it is giving you -2. This is strange. Okay. Okay, let me 1 second. Give me 1 second. Maybe how is it using this? 1 and 2 is 2. Okay. Um, -1 and minus, no, 2 and -2. 2 and -2 is -2. Okay. -1 and -2 is -2. Okay. -2 and -10. -10. Okay. All right. So the way how it is working is it will return bigger value for positive numbers, okay, and return smaller value for negative numbers. That is the catch here. So, and irrespective of what it is returning, the answer will be a true value only. So any other number is true. So if you have any other number other than 0, only and only if you have 0, it will return 0. It doesn't matter what you provide 0 with. If you type mat.infinity, see, it will return 0 only. Anything with 0 is 0 only, basically. That's what I'm trying to say. Okay, here 0 is this false, here also false. Okay, this is also again false. That's why if you pass 0, it will return false only here, all three cases. Only and only if you have any other number other than 0, you will get some value, whatever the value is. Now this value will be greater, bigger value for positive numbers and smaller for negative numbers. That's what you see the behavior here. Okay, so between math and infinity and -1, again we don't know whether math dot infinity is going in positive direction or negative direction. For assumption, let's just say it is going in positive direction. Even though it is going in positive direction, because you have negative value, it is giving you negative value only. Okay, so if you pass a negative value, you will get a negative value, and between these two values that you passed, you will get the smallest value. Is that clear?
Yes, yes.
Okay, now we will check one more thing. Empty tuple, okay, and 2. You see what is happening? This is false value. Okay, empty tuple is a false value. 2 is a positive value. This is false value. This is true value. Hence, you are getting false value. Okay, here. So this empty tuple, square bracket, empty set, even empty string. This is empty string. Okay, and you can add let's just say 200. You'll get empty string only because it is false. False and true is false only, so you'll get empty string as false. And then likewise you can test it out. You have empty set also, and you can, even if you provide it with the infinity value, you will get that empty set only, false value only. False and true is false. Okay, so we essentially
Sadik,
Mhm.
sorry to disturb you.
Yeah.
This -1 and -2, the IDs are like bigger or smaller?
These are
If
smaller
we type
values,
the
right? Negative direction.
no IDs for this
No, they'll be positive
-1 and
only. We can
-2.
check.
Okay.
ID of -1 you're saying, correct?
Yeah, -2 and -1.
Yeah, okay. So it will be positive only. See, this number is this, what this number means. Okay, I'll give you one simple example. Let's just say you have hard disk, right? In the hard disk, how are the addresses stored? It starts at somewhere here, okay, which is 1. This is your 1. This is your 2. I don't know how to write 2 ulta. This is your 3. Okay, this is your 4. Okay, uh, and this is your 5. This is your 6, and after this again it will continue from here, right? So the point I'm trying to make is all these addresses go from 0 to whatever the number is, maximum number that comes here. So that number will always be positive. Now what id is saying is this address allocation number, so it can't be negative. It will never be negative. ID value will never be negative. Okay, even though your value is negative. That is why I said equal to is comparing the value, and ID is is comparing the address value. Is that understood?
Yes, Sadik.
Okay, yeah, so this is just one this thing. You can imagine capacitors also. In capacitors you have addresses stored in kind of stacks. Okay, so basically addresses go from 0 to you'll have multiple capacitors, right? That's how your flash drives and all of those work. So you have addresses going from 0 to something, I don't know the maximum value, but you can just imagine. So these values will always be positive. Okay, all right. So okay, I was saying, so just remember this, whatever the value that you have here are false values. The same thing is applicable for R. Now let's just say you pass this R 200. What should be the value? Can anyone tell? It's 12.
Set
Yeah, no.
to
For R value it
200.
is,
Huh? Okay.
for R it is true and false is true only. So it will return 200 value. Okay. And let's now try with negative values, -1 or -2. Now you see -1 is bigger value, right? Now the change in difference is, okay, let me erase this. Okay, I think I kind of interchanged that. So the point we are saying here is this AND value returns bigger number for positive numbers, it returns smaller value for negative numbers. Okay, but this R is ulta, so it will return bigger value only, bigger value for both positive and negative, okay. So that's what we are seeing here. So between -1 and -2, -1 is bigger, so you will get -1 only, and between false value and true value you will get true value only, which is 200. Is this understood? Is the small difference between and or understood, this one?
Yes.
Okay, this is important, just remember. Now not value, so you can say not 5. Not is a positive
Sadik,
value.
your voice is breaking, Sadik. For me, your voice is breaking.
What about others? Is my voice breaking for others as well?
No, no,
No, it's good.
it's
Yeah,
good.
maybe Yasin, it's some internet issue at your end. Okay, so here 5 is positive value, true value. I said true value is any other value uh, other than your 0. This is true values. Any other value other than these 0 empty sets are positive values, true values. False value is these ones. So if you pay attention, 5 is true value. When you negate true value, you will get 5. You will get false value, right? That's what you are getting here. Now if I type not of empty tuple, you'll get true because this is false. This is false value. That's what we saw. Not of empty string is true. Again, uh, not of empty list is true. Okay. Likewise, if you notice, not of uh, empty string, empty tuple, empty this thing. Okay. Not of one more thing just crossed my mind. Okay. None. Not of none is also true because none is also taken as like false value only. Here you add none also. Okay. Not of none is true, always true. And not of any other number, may it be mad dot infinity, because infinity is also some number, right? Hence it is taken as true. Not of true is false. Likewise, not of let's just say mad dot some exponential value. Okay, because it is a value, some value which is other than 0, hence it is true. Not of true is false. Is this understood? And or and not, are these understood? These are logical operators.
Yes, yes.
Yes.
Okay, all right. So the next thing we have is bitwise operator. Now bitwise operator, you have to pay attention. Okay, um, bitwise operators are being used here. Okay, okay, I'll finish the easy ones. Okay, and then I'll come to the hard part. So identity operators are next. We'll look at identity operators. Identity means is and is not. Identity operators are is and is not. Okay, let's just say we'll take the same example. A is equal to 5. Okay, B is equal to 3 plus 2. Okay, now we'll check ID of A, comma ID of B. So here, because the initial value was 5, here the way it interpreted is it assigned to 3 and then it added 2. Okay, it didn't first calculate 3 plus 2. It has to assign a value first to reserve the memory, and then to that it has added 2. That's why these address spaces are different. Okay, um, so that is the one. Now if I say is A B, you see, but if I type is A equal to B, okay, let me print A comma B. A is equal to B. Interesting, because I have provided comma, that is why. Okay, now let's check. Okay, so now if you see A is B means it's comparing the, if both the operands are identical, then it will written as true. Okay, so when are two operands equal, identical? They are identical if their IDs are same. Okay, that is the thing. Two numbers are identical if their address ID value is same, and if you want to compare that address value, you use is operator. All right, is this understood? Very simple. I mean, you just want to check if something equals to something else, that is when you use is. And if you want to check 3 is not 2, you see what happened, you still got the answer value as true. Okay, but you could have also done this using 3 is not equal to 2. Okay, that is what the warning is about. You could use this instead. Okay, ignore the warning for now. But if you want to check whether the addresses of two things are not the same, then you can use is not. It's very straightforward. Is, it means same, is not means different. That's all it is. There is nothing more to it. So if this is understood, I will talk about the next operators, in and in, not in. Okay. So, and what do we have? Ternary also we have. Okay, in and not in. Okay, in means you want to check. Let's just say you have some list. Okay, something like stats number 2, number 3.14, and here in this list you want to check 3.14 in L, whether some element is present or not. That's when you use in. And if I want to do Python, okay, pi in L, so it will give me false. But if I do the ulta of it, so as in if I provide not in, negate, provide the not in, then I'll get the true value. Okay, so that is the difference. So if you wanna, while building your logic for various applications, if you wanna check certain element is present in certain collection type, so that is when you can make use of in and not in. Okay, very straightforward. Ternary operator is so on true if expression else, on false. Okay, ternary operator we will talk about in this one also, if else as well, where we provide various conditions. But if you wanna see now, I can show you 1 second. Uh, Ternary operator, um, you have a dedicated symbol for that. Okay, let me check. It's called Okay, so this symbol. So ternary operator means if you want to compare, let's just say 5 if 5 greater than 6, else 6. Okay. This is some sort of condition that you want to check. Ternary operator means there is no exact thing to be compared. The same thing, same condition can be checked this way. Let's just say you want to say uh, 5 is minimum if 5 is less than 6, else 6 is minimum. So you'll get 5 is minimum. So ternary operator is not any symbol. Okay, I don't know why I went ahead and included this here. Ideally, this should have been a part of if else statement. Okay, but ignore ternary operator for now. So ternary operator means writing two conditions in one go. So that for that only they call it ternary. There is nothing dedicated here, no dedicated symbol as well as. Um, it's not exactly doing any. Um, it's actually doing, if you notice, it's actually doing a comparison, but it's kind of with conditions. Basically for that they call it ternary, but ignore that for now. So we'll anyway talk about it in conditionals, but the other operators we'll look at. Okay, up until this point is other things understood. Are you following me? Should I increase the speed, decrease the speed, change the explanation? um, so up until this point, is this understood?
Yes, yes.
Okay. The next one is bitwise, because bitwise and assignment operators they have certain similarity. Okay, if you understand one, the other one will become easy. Um, but I want to take because we have already spent 45 minutes. Let's take a 10 minutes short break. Okay, and come back, because to explain this bitwise operator we need huge amount of time, and our meeting will end. Okay, that's why just let's do one thing. Let's take a pause for 10 minutes and come back. Not even 10 minutes, take 5 minutes. Okay, 8:45 now. It's 8:45. You come back at 8:50 or 8:55. Either way, it's fine. So 8:55, you come back at 8:55. From 8:55, we'll carry on with bitwise and assignment operators. Is that okay?
Okay, sure, Sadiq.
Okay,
Okay.
Sure.
all right. Yeah.